These are the Lesson 9.3 notes, Day 4 on rational functions and graphing rational functions. The goal today is to graph a rational equation like the one you see right here, y equals 10x squared minus 11x plus 3 over 5x squared plus 17x minus 12, and identify its asymptotes, intercepts, and holes. And hopefully by the end of this unit, you'll be able to do that even without a calculator. But to do this, we need to review some factoring rules first. The first big rule of factoring is if you have common factors, that's always the first thing you should check. For example, in the expression 4x cubed plus 12x, you can divide a 4 out of both of these terms. You can also take an x out. So if we pull a 4 and an x out, and then think, what do you get if you divide out a 4x from a 4x cubed? Well, if you take a 4 out of a 4, there's basically 1 left, so you don't have to really write that. And if you divide an x out of x cubed, there's x squared left. Same idea if you divide a 4x from 12x. 12 divided by 4 is 3, and it's a positive 3. And if you divide an x out of an x, there's none left. So in factored form, this is equal to the expression 4x times parentheses x squared plus 3. What I'd like you to do next is pause the video and see if you can factor these next two expressions. So here we go. In our second expression, you can divide out a 3. In parentheses, you'd have x plus 6. And in the last problem, you can divide out an x, and in parentheses, we'd have x plus 5. The second rule we're going to look at is factoring by a difference of squares, thinking about what do you have to square to get each term. For example, with x squared minus 9, x squared is obviously what we get when we square x. 9 is what we get when we square the number 3. So it's sort of like we have x squared minus 3 squared. To factor a difference of squares, what we do is we have two sets of parentheses. I think of x times x as equaling x squared, so we're going to put an x in the first position here. To get a 9, we're going to multiply by 3 and 3, but to get it to be negative 9, one of these 3's has to be positive and one has to be negative. So each thing that we're squaring goes in parentheses. See if you could factor each of these using a difference of squares. We'll take a look at your answer after you pause the video in just a moment. For the second expression, 4x squared is what you get when you square 2x. 2x times 2x is 4x squared. To get the number 1, we square the number 1. So if we take the 2x and the 1 and we put the 2x and the 1's inside our sets of parentheses and we make sure we have 2x plus 1 and 2x minus 1, that would be our difference of squares. Now for the last problem, 4x squared is equal to 2x times 2x. 16 is equal to 4 times 4. So if you factored this expression into 2x plus 4 times 2x minus 4, that's okay. Here's the problem though. There's still a common factor that you could take out of each of these factors we have. You could divide out a 2 from 2x plus 4. If you take out a 2 from this expression, you're left with an x and a plus 2. And with 2x minus 4, you could also take out a 2 and you're left with x minus 2 here. So with the 2 and the 2, 2 times 2 makes 4, and we have x plus 2 and x minus 2. This is the completely factored expression. So here's maybe a piece of advice. What you'll notice is that with 4x squared minus 16, the first thing you should always check is there a common factor? And here there is. You could take a 4 out of both of these terms. And if you divide a 4 out of both of these terms, you're left with x squared minus 4. With x squared minus 4, this is a difference of squares. It's x being squared and 2 being squared. What you really have is 4 parentheses x plus 2 parentheses x minus 2, because it's a difference of squares. X is being squared, 2 is being squared, and you can get to this final answer maybe a little bit quicker than the way we did here. Factoring review number 3. Trinomial with lead coefficient 1. Find two numbers whose product is c and whose sum is b. For x squared plus 8x plus 12, what we're going to try to find, because a is equal to 1, there's no lead coefficient in front of the x squared term. The coefficient from the x term is 8, and c is considered to be 12. Our goal is to find two numbers whose product, when you multiply the two numbers together, is 12, and when you add the numbers together, you get 8. Now there's lots of numbers you can multiply together that give you 12. Examples would include 1 and 12, 2 and 6, and 3 and 4. Do any of these numbers add up to 8? Well, 1 and 12 add up to 13, 2 and 6 add up to 8, 3 and 4 add up to 7. So 2 and 6 are the numbers we want to work with here. What's this going to look like? In parentheses, to get x squared, we're going to multiply x times x. To get the 12, we're going to do positive 2 times positive 6. And if you're thinking of doing the FOIL process, x times 6 is 6x, 2 times x is 2x, 6x plus 2x is 8x. See if you can factor these other two expressions. Pause the video, we'll see what you get in just a moment. So for our second example, we're looking for two numbers that you can multiply together to get negative 35, but when you add the numbers together, you get negative 2. I wrote down a whole list of numbers that you can multiply to get negative 35, and out of these four sets of numbers, to get them to add up to negative 2, I have to choose 5 and negative 7. So positive 5 and a negative 7 go inside the parentheses with x's at the beginning. X plus 5 times x minus 7. For x squared minus 8x plus 16, looking for two numbers that you can multiply to get 16, but when you add them, you get negative 8. If you do anything like 1 and 16, 2 and 8, and 4 and 4, these are all positive numbers, so when you add them together, you'll get a positive answer. If you multiply two negative numbers together, that will get us a positive product, but a negative sum. And negative 4 and negative 4 are the numbers you want to use. X minus 4 times x minus 4. The last method of factoring is probably the most difficult. This is when you have a trinomial, 3 terms, when the lead coefficient is not equal to 1. We're going to use the factoring by grouping method. And how this method works is the following. Similar to what we did before, this time you're going to multiply a times c together. Now, this is the two numbers whose product is going to be c, is going to be 3 and 6. 3 times 6 is 18. So you're going to always multiply the a and c terms together at the beginning now. So we're looking for two numbers that when you multiply 3 and 6 together, you get 18. But when you add the numbers together, you get 11. So when I'm looking at numbers like this, two numbers whose product is also 18, but when you add them together, I get 11. Numbers whose product is 18 would include 1 and 18, 2 and 9, and 3 and 6. Do any of these numbers add together to get 11? Well, 1 and 18 is 19. Nope. 2 plus 9 is 11. Good. 3 plus 6 is 9. No. So we're going to use the numbers 2 and 9, but instead of writing x plus 2 and x plus 9, we're going to replace the middle term with 2 and 9. So our middle term is going to become 2x plus 9x, and then we have a plus 6. So we're replacing the middle term with 2x plus 9x. We're not writing x plus 2 times x plus 9. The next thing we're going to do is a common factor step. What can you take out of both of these expressions through division? Well, with these first two terms, I can divide out an x, and what I'm left with is 3x plus 2. And with my second two terms, I can take out a positive 3, and what I'm left with is 3x plus 2. To finish the factoring, think of what can I take out of both of these terms? Well, I can take a 3x plus 2 out of both of these terms. And if I take a 3x plus 2 out of the first term, I'm left with x. And if I take a 3x plus 2 out of the second term, I'm left with a plus 3. This is your factored expression. Try and factor out these other two expressions. Pause the video. We'll see what you get in just a minute. For the second example, when you multiply a times c together, you get negative 24. Middle term is 5, so we need two numbers you can multiply to get negative 24 and add to get 5. I listed all sorts of numbers you can multiply to get negative 24. Only 8 and negative 3 add up to 5. So I'm going to replace this middle term, the 5x, with 8x plus negative 3x. Then what you can do is you can take the first two terms, take a 4x out, take the second two terms, take a negative 3 out. Common factor between both of these is x plus 2. If you take an x plus 2 out of here, you're left with 4x. If you take an x plus 2 out of here, you're left with minus 3. Answer, x plus 2 times 4x minus 3. In the last problem, it looks like you're going to have to multiply 3 times negative 36 to get something like negative 108, and then two numbers that add together to get 12. What a mess. But if you remember, the first rule of factoring is to always take out common factors. When you take out a 3, you're going to be left with x squared plus 4x minus 12, and this is a lot easier to factor. because the two numbers you can multiply to get negative 12 and add to get 4 are positive 6 and negative 2. And then you can just write this problem as 3 parentheses x plus 6 parentheses x minus 2. Based on this, we should now be able to factor something like this expression and be able to graph this equation, even without a calculator. To graph this equation, we're actually going to start with the horizontal asymptote first, since it's easier to identify without factoring. Remember, to find the horizontal asymptote, what we do is we look at the degree of the numerator and denominator. Here the degree of the numerator is 2, that's the biggest exponent value for x, and in the denominator it's also 2. And you may remember, if the degree of the numerator is equal to the degree of the denominator, what we do is we divide the lead coefficients. So our horizontal asymptote is going to be y equals a divided by b. Our lead coefficients are merely these two numbers, the 10 and the 5. So if you take 10 divided by 5, that's equal to 2. Y equals 2 will be a horizontal asymptote for our graph. The next thing we're going to do is we're going to need to factor the numerator and denominator. And to do this, you'll notice that our lead coefficient of these trinomials are 10 and 5, and it's not 1. So we're going to use the same rules for factoring that we used in the last set of 3 problems right here. What I'd like you to do is I'd like you to pause the video, factor the numerator and denominator, and we'll see what you get in just a minute. We've already discussed how to factor expressions like 10x squared minus 11x plus 3. The middle two terms are going to be negative 5 and negative 6 because they also have a product of 30, which is 10 times 3, and the middle term is negative 11. So if you replace the negative 11x with negative 5x minus 6 and go through the factoring steps, you'll end up with 2x minus 1 and 5x minus 3. In the second problem, 5 times negative 12 is negative 60. The middle term is 17. And the two numbers that you can multiply to get negative 60 and add to get 17 are negative 3 and 20. So if you replace the middle term with negative 3x plus 20x, do your factoring steps, you'll end up with 5x minus 3 times x plus 4. So what this means is that our original equation, the numerator can really be written as 2x minus 1 times 5x minus 3. And our denominator can be written as 5x minus 3 times x plus 4. This should allow us to figure out things like the holes in the graph. Holes in the graph are any place where if you plug in a value for x in both the numerator and denominator, you get 0. Since 5x minus 3 is in both of the numerator and denominator, we can set this equal to 0 and figure out what x would equal. Add 3 to both sides and divide both sides by 5. X equals 3/5 would be a hole of the graph. Vertical asymptotes. Well, if you plug in negative 4 into the denominator, you would get 0. So x equals negative 4 would be a vertical asymptote. This would be a point of discontinuity. Intercepts. To find the x-intercept, looking for values in the numerator that would give you 0. Now there's already this hole at 3/5, but if we make 2x minus 1 equals 0, that would give us another x-intercept. So 2x minus 1 is equal to 0. Add 1 to both sides, divide both sides by 2, and you get 1/2. There's our x-intercept. To find our y-intercept, plug in 0 for x into each of these terms in the expression. Now, I think the easiest way to do this is to actually go back to the original expression, not the factored one. Because if you plug in 0 for all of these x's, all of these terms are going to cancel out because you're multiplying by 0. And all you're going to be left with is a positive 3 over negative 12. And that's your y-intercept. Now you can reduce that value, 3 over negative 12, to negative 1/4. And now we know where the horizontal asymptote is, hole, vertical asymptote, x-intercept, and y-intercept. You should be able to graph this function. See if you can do that here on the right. We'll pause the video and see what you get in just a moment. So in our final picture, here's what we should have. We should have a horizontal asymptote at 2, which you can see right here. You should have a vertical asymptote at negative 4, which goes up and down here. The hole in the graph is at 3/5, which you can see here. X-intercept is right before it at 1/2. Y-intercept at negative 1/4. Our branches go along these asymptotes, and there's our final answer. And that's how you can graph rational functions that are factored, and that wraps up our discussion on how to graph rational functions.